Hello, everyone. Thank you for joining. Welcome to the PASS DBA virtual chapter meeting. Today, our speaker is Stuart, and he's going to talk about DevOps design principles for database. And my name is Toyob. I'm going to moderate today's session. Our sponsors are AWS and HVR. They're both companies are huge in cloud space. So I encourage all of you to check them out because without their help, these meetings won't happen. Also, you can connect with PASS outside these virtual meetings. These are Twitter handles. They have YouTube channels. And so once you go to pass.org, you can see what other way you can engage with PASS. And this year, PASS Summit is in Texas. We still don't know if it's going to be virtual or in person. They're working on it. But the call for a speaker is open. It's going to close tomorrow. So if you are thinking to submit a session to speak at PASS, you still have time. You can go to pass.org and it will take you to the right link where you can submit sessions. PASS also holds something called SQL Saturdays. They are a smaller event, but a whole day event. They happen across the world. And if you go to sqlsaturday.com, you can see details. These are a few that are coming in next month and this month. Sorry, next month and June. There is one was not showing here. That's on this Saturday. It's going to be a virtual SQL Saturday. This is the first virtual SQL Saturday ever. There will be about 20 to 24 sessions. So if you go to sqlsaturday.com, you'll see it there. This is the chapter in Virginia. They are hosting it. So I'm going to skip this slide. I'll let Stuart speak about himself, and I'm going to hand over to Stuart right now.
Thanks, Dave. So, first of all, thank you all for coming. Let me share my screen. I guess that would be the first thing to do. Let's see. Make sure that y'all can see that slide.
Yes, we can.
Okay, perfect. So, this talk is kind of a new talk for me. It's something that I've been heading in this direction. I've talked about this subject a number of times, but I really wanted to get a little more granular on the discussion a little bit. So any feedback that you have or want to share, please do so, and please use the question feature. I'm more accustomed to presenting in person, so I really like to get the interaction with people and talk about things. So let's do the best we can in these strange times of virtualization and go from there. So to start off with, I had a couple of assumptions as I was pulling this thing together. I always kind of go over this because I think it's good to know who I'm talking to and so y'all can know a little bit about me. I assume that you have some SQL Server experience. I'm assuming that you've got a background in database administration architecture, that you're learning centered. You wouldn't be here if you weren't. And you've got a desire to kind of build some modern skills. Myself, my title is lengthy, and it basically is I'm the manager of service reliability engineering for Gladiator Technology, a Profit Star solution, a Jack Henry company. And what this role is a little different than traditional database work. I started out as a DBA and a developer, moved into kind of a data architecture role, then kind of took over operational DBA work. And as my company moved into more of a cloud mentality, I started to kind of move up the food chain a little bit, and networking services rolled up to me. And then as we began to take advantage of other teams, I started becoming really focused on making sure that the services we delivered to our customers were a managed security services provider. I wanted to make sure that it was operating robustly. And so I end up talking with a lot of other people. I'm kind of a shepherding role that I don't, the DBAs no longer report to me, networking no longer reports to me, but my team is, uh, we have to have some of those skills, a lot of application support skills, so that we can kind of troubleshoot issues quickly and route them appropriately, so that we can pull team members in to help us solve problems. I'm also one of the chapter leaders for Atlanta MDF. We also put on a SQL Saturday every year in Atlanta. It's a great event. If you ever get a chance, please come join us. And I infrequently blog at codegumbo.com. And just to kind of give you a little bit of perspective that, as I have moved up the management chain, my career trajectory has become much more interested in the cultural aspects of technology rather than the hands-on, in the weeds sort of thing. So I get to think about big issues and get to play with ideas. And as such, there may be some nuances that I'm not always hands-on with anymore. But I do love the fact that we can use technology to solve problems. And as such, my goal is to motivate people to really get themselves involved and learn new things as we go along. So when we talk about DevOps, and DevOps is people talk about it like it's a relatively new thing, but the mindset of DevOps has been around for about 10 years now, and it actually was born out of the Agile manifesto and some movements on the operational side. We'll talk more about those in a little bit. That actually have roots that go back 20 years now. So this is not something that is necessarily new, but data people, in many ways, we are often late to the party because we tend to be very interested in what we're doing, and there's lots of exciting things going on in the database realm and lots of interesting technologies and ideas to wrap our heads around. And so we sometimes get so focused on those that we miss out on some of the broader conversations about what's going on in the software world. So I'm pulling this together because what we're seeing and what the movement really is to really improve the delivery of software throughout the value stream, and I'll define that term in a bit, more efficiently. And databases have to be part of that conversation. And in order to be part of that conversation, we have to kind of start thinking about how are we going to design our data solutions, our data storage solutions, in a way that align themselves with the way that the rest of software delivery is going to go. So at a high level, that's kind of the background. And so whenever you talk about that, we want to focus on where do we start. And I love this concept. This is a concept that's been kind of kicking around for a while about unicorns, horses, and mules. And really, the idea is that I'm sure that if you've spent any time at all reading about DevOps or being interested in modern software technologies, you're going to hear about things like Netflix and Facebook and Amazon and how quickly they're able to get ideas into motion and into place. And those are really the unicorns, right? They're these companies that have found ways to really improve their value stream to such a degree that they're able to quickly roll around and make changes within hours or minutes even of getting an idea. Horses, on the other side, are companies that are where most of us work. We're kind of a typical enterprise. We've got some real strong areas. We're dealing with some legacy technology. We're dealing with some new ideas. We're having to find a way to balance it. And then finally, you've got mules. And if any of you are in what is typically government or healthcare or some of the very rigid financial infrastructures, you understand what a mule is. We're very conservative companies. They tend to be 5 to 10 years behind the curves on things. Are the ones that are going to be running SQL Server 2008 right up until the end of life, and you have to pry it out of their hands, right? And so before you can really begin to think about what your DevOps journey is going to look like and what your company's DevOps journey, you have to kind of figure out where you are, right? And again, most of us are in this this horse area where we've got some interesting things going on if you can just find the right people to talk to, etc. So along that vein, right, if we're going to talk about a typical enterprise, one of the things that gets very interesting is you start talking about how do you optimize workflow and work in teams. And this is a great book that came out last year called Team Topologies. And they start talking about all these various different models of how information flows through your organization. And in a typical horse enterprise, you'll see a model something like this, where you have a team of developers, or maybe multiple teams of developers. You have a DBA team that is isolated, and the DBA team is responsible for protecting the SQL Server data. They're also usually responsible for checking to make sure that store procedures are going to perform well. They may even write store procedures, et cetera. And then you'll have an operations team that is responsible for virtualization, networking, firewall, et cetera. And the flow of getting something of an application from development into the hand of operations to where they can serve it up to customers usually looks like this: that it passes through the couple of development teams, it gets brought into a single DBA team, and then brought over into ops. And again, this is normal. And the question is, how do we get here, right? Why is this the way it is? And I'm tossing out the term dev data ops, and really, I'm not coining a new term. I don't want you to walk out of here using dev data ops. DevOps is fine. Use that term. But one of the things that I want to make sure that people understand is that each of these silos that have developed historically have very different foci. The development silo is very creative usually. They're usually future thinking. They're trying to translate business goals and objectives into tangible products or services that can then be placed in the hands of customers. The database folks, we tend to be historically protective. We think of, what's the transactional history of something? How do we trend this? And while features are being released to us, we want to make sure that it's done in a way that we can always get back to a point in time. Our mentality, if you think about backups and restore and how critical and important that actually represents most of our mentality, right? Is that we are so focused on making sure that the history of the organization is protected that we sometimes don't look far enough into the future. And operations, they tend to be very supportive, and that they're really looking at it from a maintenance perspective. Like, how do we continue to keep these things running? Yesterday doesn't matter so much as right now. And I want to make sure that I have the capacity to do what needs to be done right now. When the future is great, but I've got to keep focused on making sure that all my systems are up and running. And so what we've noticed over time is that as the needs of an organization grow, having these teams divvied up in this way and being focused in these particular areas, it tends to not scale well. And by that I mean that you get the whole idea of throwing something over the wall. Development is responsible for getting a feature out the door. They're going to toss it over the wall. The DBAs look at it and say, man, this is just junk. I'm going to kick it back. And so there's a lot of back and forth because there's not partnerships there, right? There are areas of being focused on things and working on it. It just doesn't scale well. And as we get newer opportunities and our compute power begins to grow and our advantages get to grow, we've got to find a new paradigm for working together. So if this is not where we should be, how do we get here? And particularly in the case of database systems where there's both the creative and the maintenance activities involved, right? Database administrators all know how to sling decent to good SQL, right? I mean, if you're a DBA, you're going to know how to write some code that works well with the database. So there's that creative aspect. And what happens is that more often than not, I've seen organizations where people actually just defer store procedure writing to a DBA, or they hire a development DBA, or someone that's totally focused on just that creative aspect. There's also the maintenance aspect. We talked about backups and restores, server configuration, server builds, performance troubleshooting issues, right? The question is really, why do these skills get siloed into a team that is neither development nor operations? And you may roll up to one or the other in an organization, but most DBAs aren't hanging out with the network admins. That's one of the things we found out in our team, is that there's a very tough language to break there. And we run into it now when I have application developers in my team as well, that they don't always talk the same language as my DBAs or my network administrators. And the reason that database systems kind of got broken out was that, the whole relational database system, modeling system, was developed in the early 70s. And it was a compensation for the growth of the database versus the cost of the hardware. In other words, SQL works so well because we use normalization, we use strong typing, and it allows us to have a much smaller footprint on disk, which allows us to get much more data on the disk footprint and still adding to the performance capability. If you think about hardware in the early 70s, right? And I know that a lot of you don't go back this far, but back in the early 70s, you'd see mainframes, right? And mainframes, disk storage, introduced in the early 60s, still kind of prevalent in the 70s, was things like the IBM 1311, which was kind of reusable storage and removable. And each of these trays roughly cost $2 million in 1967. And these were some of the best figures that I could find at the time. And that translates into about 15.5 million in today's dollars, and it's 2 meg of storage. And so when you're talking about database problems that we have progressed and grown, that's where we started with SQL, is back on these very, very small footprints. So cost cutting and designing databases that were very small, very tight, performed well, was a very, very valuable skill, because the cost of data storage was so expensive that in order to really optimize it, you wanted a team of people that very specialized in that sort of area. So the same people that were responsible for safeguarding that data, they had to understand the schema, right? And so you ended up with database engineers that probably had some development experience, were mostly interested in writing the files. They were also, castaways from the operations team, and they were very interested in making sure that things were backed up, so they had to learn to code. And what happened is we basically created magic. And that magic was we figured out ways to store an awful lot of data on a very, very small footprint. So at the end, the reason why we're separated off into teams is that we're actually wizards. And wizards don't get along well with other tribes very often. So please, if you have any questions, feel free to ask and tell you about. I don't know if there's anything out there, but we can just check in.
No, there was just a comment that make sure you're close to the mic, but I'm not hearing any fading. There's one user said, he or she had a problem with that. So, but I'm hearing good. There's no other question at this point.
Okay, I'll lean in. So looking at the different teams and looking at the different strengths, you have the developers that usually speak multiple languages in terms of coding. They often understand the business goals, and they can focus on the value. You'll have database administrators that have a single language. We're usually very, very versed in T-SQL, although that's changing somewhat. For people that call themselves DBAs are also showing things like R and Power BI and Power Query and analysis services. So that's kind of growing a little bit, but still it's kind of a limited foci when you compare it to traditional developers. And we tend to focus on performance. And on the operation side, they tend to understand the costs and focus on making sure that the services are reliable. And as you can see, that each of these have 3 different areas. And what happens is that communication can begin to kind of break down between these different teams because you get so into the weeds that you're looking for. So what DevOps does for us is it's a way of shifting our thinking. And we'll talk a lot about shift left, and you'll hear that term bounce around. And what shifting left means is that if the flow of the delivery of software in an organization moves from left to right, from requirements to design to code to test to acceptance to deployment and production, shifting left means you begin to put more resources earlier into the pipeline. And the further ahead in the pipeline, the further to the left in the pipeline that you can put resources, the less expensive it becomes to operate when it gets out to actual production. So you bring your database administrators to the table, you bring your network operators to the table in design, and you make sure that they understand what's going on and get involved in the development process so that you can do that. And there's reasons for this. One is the Agile movement, which completely emphasizes the speed of delivery, and the Lean movement, which emphasizes the elimination of waste, and then the fact that we're moving into a cloud model where you have exponential computational power. And so we're able to deal with much, much more information on a far grander scale than what we were originally used to. So having a team of developers that focused on solving a project and making it work in a very small environment, and handing it off to a team of database operators for them to test, and then handing it off to the team of operators and network administrators for them to deploy, um, that that doesn't work when you start talking about problems of scale. So what your goal is really to try to get people to tackle the bigger operational problems earlier in the design phase, and have those conversations up ahead. So um, DevOps itself, just to kind of give a real brief overview, it is, if it can be summed up in a single sentence, there's multiple ways to do it, but I like this one. It's focused on delivering quality faster, and that's really what it is. It's just it's a way of thinking about solving the workflow and software delivery problems, the design problems, and beginning to get quality faster. It's a philosophical approach. There's not really a methodological approach. You'll hear various toolkits. You'll hear various tools that are talked about. There's areas that you can focus on, but really, just the fact that you're having a conversation and a change in a mentality is the foundational aspect to DevOps. There were several great fundamental presentations and ideas that really contributed to this. And I've listed them there. If you have not read The Phoenix Project by Gene Kim, it's a wonderful read. It's not a handbook. It's a business novel, and there's now a follow-up novel called The Unicorn Project, which I've just started, and it's excellent as well. But it begins to kind of lay out some of the fundamental principles of DevOps. And when you start talking about DevOps, the way the Phoenix Project lays it out is they talk about feedback and flow. And what flow is how do you begin to get an idea of value from business, the development team, to the customer via the operations team. And so that's the first way. You need to start thinking about what's the delivery mechanisms like? How do we speed that up? What are the tools that we can use to do that? And then once you've done that, then the question becomes, how can you quickly get information from the ops team back into the hands of development? How do you improve your feedback? What systems are you using? Is it a ticketing and support system? Do you have multiple ticketing and support systems? Are your developers working out of one and your ops team working out of a different one? Are you monitoring? What are your metrics? How do you know that something is performing the way it's supposed to be? And how do you tell people about that? Once you've begun to amplify those feedback loops, then you can begin to experiment and get ideas moving faster. And you do this through more frequent releases of smaller code. So you try a little idea, you get it out into operations. If you can get immediate automatic feedback into development how it's working, then they can take that feedback and then they can begin to go through the process again. Usually when I talk about this, people ask about, well, what about QA? And QA is part of the development process. It is that final check before code is ready to leave the development pipeline. So they should be able to represent the business interest. So in the Kim model that's placed in the Phoenix Project, if you talk, when he talks about QA, he really envisions QA as part of the development aspects of things. Although he does talk about broader communication and the whole thing. So there's really two commitments that you have to make whenever you start talking about the DevOps pipeline. And the first commitment really is that you need to strive to take perspective. And all that is simply saying, that I know how my team works. I know what my team is responsible for. I need to understand the bigger picture. So I'm going to hang out with some developers. I'm going to hang out with some network administrators, and I want to understand what the value that my team brings to the table is in terms of the broader picture. And then you have to strive to continuously improve and look for those opportunities to find ways to make your job easier. And I think this is something that learning-centered people do naturally. Most people that I know, even if they're very focused on maintenance tasks like backup and restoration, they figure out ways to script and automate as much of their job as possible, so they don't have to spend so much time on the manual stuff, and they can spend more time learning something else. They're going to focus. You're going to focus on learning PowerShell to help rapidly build servers or deploy databases. That idea of continuous improvement is all about finding metrics and finding ways to say, how am I performing now, and what can I do differently to do it better? And so, the opportunity is there really to take these two perspectives into mode. So it's all about the value stream. And what the value stream is, it's that series of activities that create a flow of value to the customer, right? And Donovan Brown, I don't know if any of you have seen any of his videos. He's a very fun, engaging speaker. He is the Microsoft DevOps advocate. And he really, he came up with the definition a while back, and I really like it, that it's the union of people, process, and products to enable continuous delivery of value to our end users. And the idea is that if you step back and look at everything that it takes to get value into the hands of your consumer, it's a lot. You might have coders, you'll have operators, you'll have management, salespeople, customer support representatives. You'll have processes like governance and compliance, release, disaster recovery. You'll have products, applications, your databases, your servers, and your networking infrastructure. And there's no way that anyone can be familiar with all of them. But by coming together as a team and having those specialized backgrounds, but being willing to discuss and being willing to share, you can begin to get a broader coverage of that and understand how your piece of the puzzle fits in. Developers or database administrators, particularly those on the operational side, they know things like RTOs and RPOs, where you have recovery time objectives, recovery point objectives. We design it into our backup and our maintenance strategies because we want to make sure that our maintenance windows don't interfere with other busy things going on. And developers have no clue about that, right? That's just not part of their language in normal everyday conversations. They're just trying to make something work, and so they code and they'll make it work under the best case scenarios. They'll train and make it work under the worst case scenarios, but those don't often include the normal scenarios, right? And so having those understanding and having those conversations about scalability and how this will impact the database when you suddenly go from a few thousand rows of data to several million rows of data, that's a great conversation to have, and that can alter and affect the design of the database and the solution that you put out there. So DevOps, I talked a little bit about Agile. I think if you look at the different mentalities, this is really where the breakdown of the responsibilities kind of begin, right? The dev cycle, they're going to be using some sort of Agile methodology in a modern shop where they're worried about sprints or other iteration-based applications, so they're delivering code as quickly as they can. Their job is to design, to build, and to release. And then the ops side of the house, they're usually coming from an ITIL background where they have to worry about things like change control, compliance, and governance, and configuration management, et cetera. And so their goal is to deploy, to operate, and to optimize. And all of those goals are part of the value stream. And all of those goals are part of the DevOps conversation. And the earlier you can begin to talk about issues with optimization, operation, and deployment and get them into your thinking about design, build, and release, the less expensive those operations become in an operational environment. Dev hardware is cheap. Dev cycles are cheap. Developers are not cheap. I didn't say that. But when you build actual hardware and actual software, it's much easier to discover a problem before it becomes visible to customers, and saves a lot more time and effort and value. So your goal is to really get those ideas and those concerns out of the way up front. So now I'm covering again another way of slicing it, and this one is also important to me, is you can talk about CALMS. And CALMS is another way of looking at DevOps, and CALMS talks about these 5 domains, these areas of interest that you can begin to work in. And the reason I bring this up is because I want you to go back to your job, I want you to go back to your team and start thinking about, these are the 5 areas that I can begin to make change in, where would I begin? And this was originally proposed by Edwards and Willis, and then Jez Humble suggested that you add an L because you make it a word, because it used to be CAMS and now it's CALMS. It's a great framework. It talks about culture, automation, lean, measurement, and sharing, and these are the 5 areas that you can begin. However, I turn it up on its side a little bit because I think that when you talk about making changes within an organization, one of the very first fundamental things you have to really get everybody on board with is the concept of lean, and that's eliminating waste. And everybody has to be on board with the idea of looking for efficiencies. If all members of your team that are involved in your value stream delivery service are not involved with eliminating waste, that's a struggle. And so that's one thing you have to begin to do. The second thing you need to talk about is how do you measure it? How do you show? How do you say that we're improving? Once you've done that, then you can kind of move into either more of a tactical or strategic area where you're looking at things like automation, sharing, or culture. We're going to talk a lot about automation in this conversation, mainly because software design and development, more particularly when you start talking about database designs, you're really trying to gear things toward that automation side of things. So I've taken 30 minutes and I've run through half my slides, and we really haven't even gotten to the good stuff yet. But I wanted to just pause here for just a second, just to make sure everybody's on board with me. We're in a good place, and we can continue to move on.
So Stuart, so for one question, and I'm going to read it as is, because I think we all struggle with this. With whatever the team frameworks, automation and cloud, the one thing that I want to get from here is if there is still a good future for DBA.
Oh.
And there is a comment from Shane. It all comes here. Okay, so I think that's just a comment, but that's a question. Otherwise, there's nothing else in the question window.
Let me address that and say absolutely, right? What I will tell you though is that the role and let me back up just a second and we'll talk about this a little more. I think that the role of a DBA will change significantly in the future when you start talking about things like automation in the cloud, particularly when you look at database as a service and more of a platform mentality where there's much less configuration aspects of it on the server side of things. There will always be data design work. What it may mean though is that the role of a database, the role of the skill set that we traditionally call database administration will probably split into 2 sides of the organization. And this is just me conjecturing, right? I think you're going to see a lot more need for people that are well versed in understanding data and understanding things like both schema bound and schema less data storage models. So people that are very well versed in running SQL are also going to have to learn things like the not only SQL, no SQL kind of movements, document databases, et cetera, because it's all data, right? And so they're going to be responsible for designing and developing architecture. And so their roles, their jobs will move more into the development side of the house and get more accustomed to doing things the way that other developers are doing things. There will also be a need on the operational side of the house to deal with things like backups and recoveries and configuration, but you'll see an explosion of databases on servers. And so you can't be as well versed with the business logic on the operational side of the house. So the goal is the folks with the business knowledge and the business logic, if you're interested in being more of a database developer and building those skills, the opportunity is there to get more breadth and start dealing with other data types and other types of data storage mechanism. On the operational side, you may be dealing with fewer servers, more databases, and have to get a lot more depth on your side in terms of understanding backup strategies, RPO, RTO sorts of things. And so, yes, I think the jobs are going to be there. I think that there's going to be more specialization in some ways. SQL Server as a platform has become a very diverse platform, and that's both good and bad. I think that there's a lot of benefit to the way that SQL Server has evolved, but I think especially as you begin to look into things like cloud technologies, et cetera, that a lot of those operational concerns are going to be replaced with more architectural decisions. And so you'll be more involved with making sure that recovery strategies work and that you have enough space and compute time. And there'll be a need on the design and development side of the house to kind of facilitate that. So, but that's a great comment, and I love that conversation. And you know, if we ever get past this COVID thing, I'd love to find you and have a beer with you, and we could talk it over in depth. So, I think when we talk about database people, and when it comes to challenges about getting involved in DevOps, you know, data retention is a big issue for us, right? That, and it really comes down to that from the DevOps mentality, servers are cattle and not pets. And the idea is that DevOps mentality, you know, there's a reason that the container movement is taking off with DevOps people. It's because it's the whole idea of you can quickly spin up a server that can actually serve up your application, and you can get rid of it if it starts to malfunction. And you talk about that to the traditional DBA, and we freak out because, you know, we spend a lot of time care and feeding and loving on our servers, and we've got them configured the way that they're optimized. And so for us to adopt that mindset of, you know, yeah, we'll just spin up a server really quickly and throw a database on it because we need it, that's something we're going to have to learn to embrace. And the other piece of it is that data has to be preserved. And if you change schema, if you change code constantly, you've got to figure out these strategies of how do you manage the history of a database with the present state, and how do you migrate it from one to the other. And so that's a challenge, and there's no great answer for that. You know, I'll admit it. There's some tools out there that will help, but there's just really, you know, it's one of these things that I think that you're going to find the database people tackling as our own specific problem. We also have to deal with testing data. Some of us are dealing with highly regulated data, so we have to figure out things like data masking, and then also there's the whole scalar variation, right? You know, I've yet to meet anyone that has a development environment that is the same size as their QA environment, and it's never quite the same size as their production environment. And so trying to figure out how you scale up and handle performance concerns in those different environments, that's a real skill set that has to be fostered and nurtured in order to grow. So, but hopefully, if you adhere to some of these basic design principles, we'll finally get to the point where that can help you do that. So when we talk about designing databases for a DevOps world, the thing that you have to kind of really keep in mind is that we're ultimately talking about an automation pipeline. Now, you're talking about how you can get your database as a piece of software into an automation pipeline. So an automation pipeline, and this is just kind of a generic one, you can look at various tools that do CI/CD, continuous integration, continuous deployment. But they usually have these parts. You'll have a version control system, you'll have a build server. If the build server fails, and that's the production feedback, it goes back to the version control system. If it passes the build server, it does a unit test. If it fails the unit test, it goes back to the version control system and developers work on it again. And it's this constant cyclical iteration to try to get it into the production mode. And all of this is automated and scripted. So your first goal as a database designer in a DevOps world is understanding how the changes you make can be automated and scripted and done in a way that they can be easily tested and deployed to production in a measurable fashion. So we're going to start with some of the basics, and these are common regardless of whether or not you're talking about DevOps or more of a traditional model. And that is, first of all, whenever you talk about database design, you've got to talk about normalization. And Lewis Davidson does some of the best work that I've ever read on database models and normalization and rules. And there's no way I can replicate what he does, but I should have put his name up here so y'all could go and look him up and listen to him. He's a great speaker. But really, when you talk about databases, you know, you have to first get this first step of going, you know, what is our data model going to look like? How do we normalize? And your goal is to get to third normal form or better, right? Then databases will perform best in that third normal form fashion. And then there are some payoffs if you begin to go into these additional modes as well. But if you're not there yet, if you're dealing with heaps and tables that have uh, no primary key, and I'm not talking about a surrogate key, but there's just no way that you can uniquely identify a row, that's a data modeling problem. And that's one of the things that you need to address, because that has the potential to break later on down the line. Even though it may not be breaking in your test environment, once you get to the operational environment, you're going to encounter a scenario where normalization matters. Beyond just normalization and talking about values for self, you also need to be looking at things like typing, because typing can become fundamentally important, particularly when you scale. If you are storing data in the wrong type, you can waste a significant amount of compute and storage resources by using the wrong type. So making sure that you map your business model to the appropriate type and making sure that you normalize your database, that's the first basic step. The second basic step that we really need to consider and talk about is, what's your approach to your business logic? And those of you that have been along for the ride for the longest time have probably gotten into great discussions and arguments with developers about the three-tier model. It used to be the idea that you could have no business logic whatsoever in the database, right? That a lot of people just wanted the databases to be dumb. And so you'd have a presentation, you'd have your application there, and then your database would just basically be tables, possibly views, no such thing as stored procedures or functions, right? You do all your CRUD at the app level. And one of the things that we found is that can cause problems, particularly when you deal with larger footprints, because database servers are very efficient at doing CRUD work. They're very efficient at doing create, reads, updates, and deletes, whereas application servers, which have to do calls, are not often that efficient at it. So there's been more of a movement toward a data gravity model, where you put the compute closer to your data. So you put your business logic inside a procs and function, store it inside of your databases, et cetera. Either approach is fine. In a DevOps design model, you need to really pick one or the other. And I'll tell you why when we get to the next slide, but it becomes, again, problematic if you have business logic stored in two different places. And those you may have experienced that if you run into a problem, you don't really know where to look, right? So the third phase of this is really, how do you design with operations in mind, right? You want your developers to sit down and understand how this is going to work. How big is your database going to be? Where do you troubleshoot problems? Is it a stored procedure? Is that a possibility? Is it indexing strategies? Is it the fact that your application has your business logic in it? Now you got to go troubleshoot that. What sort of backup strategy will you need? Full differential file group. Sometimes you may not need a backup strategy in specialized cases like staging databases or other tools such as that, right? You need to talk about things like RTO and RPO. What's the encryption and compression impacts and necessities? All of these begin to factor into how well your application will deliver value to the customer. Because if you have to have certain encryption and compression strategies to do backups and restores, that's compute power. Compute power can translate into compute problems. Compute problems can translate into customer problems. So if your designers aren't thinking these things through early on in the process, you're missing an opportunity to avoid an issue later on down the road. You should also begin to design your database following some of the caveats of traditional service-oriented architecture work. And I put this, I found a great definition here and tossed it out there that, when you talk about a service from an application perspective, you're talking about a logical business activity with a specific outcome. You build an application that encapsulates that business logic. It's self-contained. Services tend to do one thing or maybe two things, but not 10 things. They tend to be very, very small. The idea is that you'll call a service for a specific task. It's a black box. Consumers can just say, go get me something, and the service will return it The consumer doesn't have to know how it works. And you can actually have a service that's comprised of other underlying services. But the whole benefit of a service-oriented architecture is it's a very building block mentality, and it becomes easy over time that if you run into issues, you can just swap out the services. And you can begin to take apart one service or alter the guts of the service, and the consumers are never impacted. You don't have to go and deploy your whole application or run through an entire MSI or multiple MSIs and hit multiple servers. When you're deploying a service, it should be very simple to upgrade and do this, right? Databases are similar in that, you want to encapsulate logical business activity with a specific outcome. If there's a different data store for the different type of data, you're going to encapsulate that differently. And by that I mean it might be a SQL versus no SQL. But the goal is that you want to limit your applications to logical boundaries. A database should serve a single purpose. It should not depend on multiple databases, right? To make the database itself work. Now you might have an application that talks to multiple databases, but databases should be independent of each other. And it goes back to this backup strategy that if you're going to restore something to a point in time, it should be okay to just restore one database and have your application back to that point in time. You should use ETL processes to synchronize across services. And one of the things that I mean by this is that for a long time, one of the benefits of beauty of SQL Server was the cross database query, right? And it really came into use because the idea is that you have a single source of truth for any given data set. And so if you have a database that needs access to that other data set, it should just be able to reach across the wire to get a copy of that data set. And so you do a cross database query where you begin to join across the databases. The problem that you run into with these sorts of scenarios is that you've now created a dependency where, again, if you have to go to restore mode, you now have two databases that you have to get back into the same points of time. Or if you need to move a database, then you have to go and figure out what the conversation is like and move it from a cross database query to a linked server query. And those can be problematic from a performance wise. We have enough space and compute resources now exponentially that you should be able, in most scenarios, to duplicate the data that you need. Business analytics have been doing this for years when they look at things like reporting warehouses, right? Is that they've taken a transactional normalized format and done some transformational work through an ETL process to get it into a format that satisfies reporting needs. You've duplicated your data. You started with a single source of truth, and there still has to be an effort to synchronize that single source of truth with now a different source of truth. But the goal is really that you have decoupled reporting from your original transactional processes. It's the same way now, right? That when you're designing a database, think one database. How does everything need to go into this one database, and how do I get things into it? This will eliminate cross-database and ad hoc queries. And if you're dealing with underlying services out of database, you're going to run into trouble anyway. So if you're starting to think of like, oh, how do I make this be a database of databases? Then you've got the wrong mindset to begin with. Just don't ignore number 4. Just don't deal with it when you're talking about databases, service level architecture. I wanted to show just kind of an example, and these are some of the challenges we face with one of our applications that has grown organically over the last 20 years. And on the first model right here is we have a single database, and each of these circles represents a database. And you can see that this single database has dependencies on 5 other databases. So if I need to restore this database to a particular point in time, I have to touch 6 databases to get there, right? Because I need to make sure that all of these are in synchronization, and because there's actual cross database joins and queries running from within that actually do this. This becomes problematic when you begin to scale it out if these databases all have dependencies on other databases, and that's what the second model begins to represent. And so what happens is that I can't alter or tinker with the first database, the Kiwi database, too much, because there's all of these downstream dependencies. If I've tried to move it to another server, I've got to go through and hunt and find all of these dependencies and find ways to reroute it. This is a problematic, and again, it's one of these operational problems that has grown up out of the fact that development tried to solve the need to not duplicate data early on, when in reality we could have solved it operationally by saying, let's add more resources and make sure that Kiwi has everything it needs so that for I can do the backup and restores as I need. So the next major design principle is incrementalism. And really what happens in DevOps is that small changes add up to big changes. And so the idea is that as things, you need to release small, you need to release often. Think in terms of what's the smallest change you can make with subsequent dependencies. If you change a column, what are all of the dependencies on that one column? And bundle that up as a release and push it as quickly as you can. Don't sit around waiting to get a whole database redesigned and re-architected before you get out there. But you need to be able to get changes in as quickly as possible. You can use views to kind of help with that transformation. Now, one thing that I think that many database designers and developers have struggled with is the whole idea of a versioning strategy. This becomes critically important when you start talking about releasing a suite of applications. You need to know what version of your database is supported by what version of your application, known as the application catalog. So you need to come up with some kind of versioning strategy. You can do a table, and some of the tools out there do this for you, where you can do a point in time kind of model where you set like an extended property on your database, where you specify the version and increment it accordingly. So it becomes very easy when you're troubleshooting problems to say, I'm on version X of my database and I'm on version Y of my application. Are these two things compatible? And if they are, then you can begin to dive into the problems. If they're not, then that opens up a whole another problem that you can do. So when I'm talking about databases, we talk about automations, this is one of the first things that I think everybody has to get their heads wrapped around is you need to source control your stuff, right? Database administrators, engineers, we've been very, very slow to get into the source control cycle. There are some good tools out there, and they're getting better with every release of Visual Studio, et cetera. So there's no excuse anymore. The whole idea of source control is not like a backup. It is more like a making sure that you have a source of truth that everybody has access to. Your developers, your operational folks, et cetera. Everybody should be able to see what's in source control and understand what a specific version or point in time it's supposed to look like. This becomes very useful because you begin to migrate and roll from version to version to version. And if you can begin to package things together inside of a release cycle and put them all together, you need a good source control system for that. So what goes into your source control system? And I apologize, I'm picking up speed, and it's obviously because I talk too much. But what goes into your source control system? You know, you're going to need to put your DDL, your schema. You'll need to put indexes, name statistics, basically everything that makes your database a database. You should be able to deploy an empty version of your database directly from source control at a given moment. This is all part of the automation pipeline. That if you want to build a QA environment, you should be able to just push a few buttons and build your database and have it roll out. Included with your schema, though, one of the challenges that is unusual for database people is the whole idea of a lookup value. That if you have certain settings or configuration settings that you've stored in certain lookup tables, those tables need to be stored as part of your schema, and as well as security roles. What this means is that there's two complementary source control strategies, right? And you can use either one or both. And so, but they're very different, and tools will do it differently for you. There's a state-based strategy, which is strictly the scripts that you have for comparing your schema. You store your schema in your source control, you store your target schema, you compare, you generate a script to get to one to the other. It's very simple to implement that sort of a methodology. It is difficult with most tools to store metadata like a lookup value. On the other hand, you can use a migration strategy, and the migration strategy is where you build actual scripts to get you from one point to another. You're not necessarily storing the scripts, you're not necessarily storing the schema itself, you're storing the scripts to create your database. And it's a little more difficult to get your head wrapped around it, but The benefit of it is that you can do some very complex installation and rollouts to this. If those of you that are familiar with the Redgate tools, and those are just the ones that we use in our shop, they have Redgate source control or SQL source control. That's a state-based model. They have SQL change automation, which is the migration model. They complement each other very well. They can work together, but you can use one or the other depending on what you're going to do either way. So all of this is leading up again to what we talked about, the grand facade. What you're trying to do is get your databases ready to be automated, where you can actually build a pipeline of tools to automate your software builds. So you should be able to make a change in development, change an index, push it into your build server, have it build, have it tested in your QA environment, have it come out of your QA environment directly into production with little to no intervention whatsoever. All of this goes straight flow through from a CI/CD. And what I'm challenging you to do is to understand what are the design elements that are necessary to make this automation thing happen. I put this, the graphic is the easy button, and I don't know if y'all have ever seen the OK Go video where they do the Rube Goldberg machine, but it's fantastic. But that is that automation sounds phenomenally wonderful and exciting. It's very, very difficult to implement. And you need to actually spend some time figuring out what your strategies are to get there. But the benefit to automating is that you get a major increase in quality. Smaller changes get caught sooner. If your systems are automatically testing as they go and failing in build, you can have daily build reports that tell you what bugs you need to work well before it gets in your operations system. It also allows you to do iterative testing, which allows you to improve your testing mechanisms. I think that I've worked with several QA teams, and QA teams tend to be they often struggle with keeping up with writing new tests because they're usually involved in doing a lot of manual work. If you can get into an automated ability, it buys you so much more time to do better tests, to write more tests, and testing is really the key to getting that improved reliability. So just a few closing thoughts. And there's a couple of criticisms of DevOps. And first being is that it's too much dev, not enough ops. A lot of emphasis on DevOps is emphasizing the development cycle. And we tend to kind of ignore some of the operational mainstays like maintenance and infrastructure. And the truth is that we need to encourage developers to look right. That's been a large part of this conversation. But operations also needs to figure out ways that they can automate the mundane stuff, the maintenance and the infrastructure, so they can buy more time to do this planning work. So while DevOps tends to be focused a lot on software delivery, there is opportunity here for operations teams to also learn and begin to pull from the development team and learn strategies about how do they write better code and better scripts to automate their day-to-day jobs. It's painful to bring all voices to the table. Culture is tough to change. Middle management's usually engaging in turf wars. If you have a database administration team and a development team, and they're, it's tough to say, hey, you guys really need to combine and really need to work together more often. And so that's something to get over. You got to have both bottom up and top down drivers to kind of resolve this. And so you need somebody in the executive seat that says, no, we need to do things better, faster. And then you need a team of people that are actually hands-on and trying to do better and trying to work through problems. And finally, change control, auditing, and compliance, particularly in classic ITIL implementations. And I put that in quotes marks because very few people are actually fully ITIL. They just seem to borrow ideas from ITIL and do the best they can. But a couple of the ideas that come out of ITIL that most people latch onto is the whole separation of duties, that they don't want developers having access to production environments, and they don't want operations folks having access to source control. There also needs to be change control processes. They want to know who changed what when. And in reality is that processes can be automated too. And so there are ways, particularly if you have a great build pipeline, that you get all of this auditing information built right into the pipeline. And so there is DevSecOps conversations that go on where they try to satisfy these needs of compliance, and that is a real thing. where people try to bring the security folk to the same table as the dev and the ops folk. So that's it. I feel like I've rushed through it, and I think the number one feedback I'm going to take for myself is I got to cut out a lot of this material. I always do that. But if you have any questions, there's my contact information. I'd love to chat more about this with you. I'm available on Twitter and try to engage there pretty often. And these are some great books that are out there that I've read over the last couple of years and have really impacted me. That if you get a chance to pick them up, there's some really cool ideas out there and some really good writers that are fun reads, easy reads, and they will change the way you work. So, and that's it. So, any questions? I'd love to hear feedback from you.
So Stuart, thank you for that. I know we are up to the clock at 1 o'clock, but there's just 2 questions. I'm going to read those for those folks who can, stay with us. So I'm just reading this. What if you have dependencies between DBs or even instances? I think that came out in response to what you were talking about earlier. And so I'll let you take that, and there's another question left.
So my recommendation is that if you have those dependencies between your databases and instances, that your application best, and the optimal state would be to eliminate them, to find ways to consolidate your data within a single container, the database, on a single instance. If you need to have databases, or if you need to have connections between databases, in reality, you should probably build some sort of middleware that has connections with them. And the reason being for that is that it's much easier to change the couplings inside of an application location if you need to move an instance or shut down an instance or point something to this, than to go through a single database and find all of the pieces. There are workarounds. You may have experimented with synonyms, or you may not have. And synonyms are kind of useful tools to have. The struggle that you have with any time that you have data stored in multiple places is that when you try to get them to talk together, you want to make sure that the conversations they have well-defined interfaces and well-defined endpoints, because you need to always be thinking in terms of, what if I have to change this at some point in the future? How do I break this coupling, and what's the easiest way to do it? It's far easier to do that at an application level, and it's much easier to just say, I'm going to put all of my data in one place if it's necessary for me to restore it all one time. So, those are really the kind of the strategies that I would encourage you to do. Is again, your end goal is to basically decouple databases at the database level by either putting your data in one place or using some sort of application tool to act as the intermediate bridge, and let it be the piece that needs to change. Well, that's a good question.
Great. So there are a few more just came in. One is, what is the name of the database design flow? I guess I know it's probably misspelled at the last word. So what is the name of the database design?
I'm not sure I understand that question, actually. So
yeah, okay. So let's move on. Thoughts of integration process like SSIS and ADF dependencies.
I haven't worked enough with ADO or SSIS to really get into some particulars or specifics there, but software is software, and so I do remember having conversations with some folks about SSIS being difficult to get into a source control. I'm hoping that with each iteration that they'll get better with that. And I think with what it's Data Factory now, is that what they're encouraging here? Microsoft is moving toward. Again, it kind of goes back to the idea that you need to have a source control process. You need to decouple where it makes possible, go back into this, go back into a service-oriented architecture where your database is the central store of activity, and any pieces that talk to it are done through a well-defined interface. So SSIS is a great tool for that, because you can define interfaces by defining either connections or data sets, et cetera. And they're actually using the interface itself. But it becomes a separate piece and component from the database design itself, if that makes sense.
Okay, I think I got a follow-up question. I think what I was asking you, and you said it didn't make sense. I think what the attendee was asking, the name of the book for database design related to normalization mentioned earlier in the meeting.
Oh, right. It's Lewis Davidson, and I think it's called it's Professional Database Design, I believe is the name of it. I will look that up.
And I just want to make a comment for
I can.
everyone that the slide and recording will be available in our archive website. I put the link in the chat room, so if it was in the slide, you will be able to look it up later on.
Okay. And I'll go back and look for it, and I can probably upload. I'll upload something to that if I get the name right. But it's Lewis Davidson is the author's name, and I think the name of it was Professional Database Design is his latest one. But I'll have to go back and get that. So thank you. Sorry, that's a great question.
Yeah, and there's two questions from the same attendee, so I'm going to read both, and then you can answer it in one go.
Okay.
Makes sense to put the SQL database in different container from the application. And from the same attendee, how to incorporate performance testing in the DevOps process.
I missed the word before testing, but
how to incorporate performance testing in the DevOps process.
That is a big challenge. I will admit that. So so when it comes to putting container, so let's talk about the container thing first, right? Is that a container should represent the smallest amount of shippable code that is necessary to perform a business function. So if you have a database that is exclusive to an application, then it could potentially make sense to do it all in a single container. Because if that application is only talking to a data store and only getting information out of the data store, and nothing else is talking to that database, then yes, it makes sense to put it all in a single container if you're going to do that. If you ever run into the need and I'm not a containerization expert, so the beauty of containers is that they ship exactly as they are configured. So when dev sets up a container, it's a closed box. They pass it over. It runs an operation just like it is. So I'm still kind of learning my way around use cases for particularly large scale databases. I haven't really found a great use model where I see for large scale. I think they're great for ETL processes. I think they're great for very dynamic data where you're going to scale out, et cetera. But it's a different mindset for me now. But the idea around a container is that it's a logical encapsulation. So if there's only two things and they only exclusively talk to each other, sure, put them in a single container. If there's any opportunity there for it to be a many to one relationship, then you need to break it out and tease it out into separate containers. When it comes to performance testing, if you have vast scalar differences between your environments, there really is no easy 100% bulletproof solution for it. If your QA environment cannot replicate the configuration of your server environment, of your operational environment, you are going to run into struggles when it comes to doing performance testing if it's that important to you. If you can use trends and say, I'm going to run it with a representative data set and do a predictive trend off of it and learn from it in the operation side and give it feedback, that's one way to handle it. In other words, you run a smaller test with a representational set of data. You take your analysis, you tune to that, and then you load it into production, and then you do some additional feedback and run that tuning process again. The other way that you can do it is you could, it's kind of a bursting model where if you're only going to make one small change, right, and then you limit your test to that one small change, and you can throw a great deal of hardware, not as much as you have in your operational environment, but you can throw a great deal of hardware at that limited data set and get some results that are much similar to production, as opposed to trying to replicate the whole database and still be only focused on testing one thing. And so you have to have spread. So the goal is that you can throw a lot of resources that are very pinpoint methodology and test it that way. So that's really the three strategies when there's a scalar variable. Obviously, I think most people want to recommend that your QA environment emulate your production environment as much as possible. That's often tough to do. For example, we manage 30 terabytes of data in our SQL Server instances, and there's just no way I can get budget to have a QA or a dev environment that's anywhere near that. So we tend to use the former model, where we'll do a representative sample, we'll do some performance tuning, we get into production, we identify problems, we get them back to dev, and they get us a patch for it as quickly as possible. So.
Thank you for that. So we have two more. Does it help? Also, so someone got the book name. I posted it in the chat window for everybody. It's Pro SQL Server Relational Database Design and Implementation, 5th edition by Louis Davidson.
Thank you. That's awesome. Thank you.
Yeah. So there's two more questions. I'm going to read the first one. Does it help to have dotted line reporting structure across teams, or possibly better for dev, DBA, ops team members under same reporting?
That is there's pros and cons to both of those. I think for most organizations, I think it makes sense to start where you're at. And so if you're in an organization where you've had rigid silos for a long time, where you've had a development team, a DBA team, and an operations team, then doing dotted line kind of transitional loaning, that model will work very well and can work for a very, very long time, right? You just you have it makes each of those teams more aware of what's going on. What has to happen, though, for that to work well is that the management of those teams have to have a good relationship, and they have to be able to pick up the whole value stream perspective and put it all together in one mindset. Sometimes that's not possible. And so then you have to kind of shift to the other model. And again, either one will work, but I think that having a team that is comprised of looking at one product line from end to end, that's kind of becoming in vogue, and it works well if you have single product lines that you can kind of put together. And I'm sorry, my dog has finally decided that he's waking up. So either model will work. I think it all depends on where you're at now and how much buy-in you have from middle management to really work together.
Okay, so the last one, and if you have to go, you can put this in a blog post. We can post it. But if you have a few minutes, I'm just going to read the last one.
Sure.
Look like requirement gathering / design phase becomes a very important, or probably it meant important aspect of DevOps, because if too many small changes being implemented quickly, they may miss the original requirement, which may not meet user needs.
Yes, I'm trying to get back to that. I think one of the things that the DevOps movement, and it kind of comes from an Agile perspective as well. Let me see if I can get back to it. Is the whole idea of an enterprise architect and having that business requirement and that conversation going along. You want to plan big but act small, right? You constantly want to have this thought of where we want to go as a company, and you want to act small, and you have to kind of keep making small incremental changes, but keep coming back to your grand design. And I think a lot of times that the role of an enterprise architect or of a software or a product management architect, they get overlooked at times. So, but yeah, I agree with you. I think requirements and design is a very important aspect of it. And again, I think it's one of those things that teams often overlook, particularly if you're used to an agile world where you're delivering on a sprint by sprint basis, right? So if you don't ever have that sprint review, which is that process of realigning your requirements and your design with where you're at now, then yes, that can be quite a problem.
Okay, so thank you. That's all the questions we have. Stuart, thank you. Thank you everybody for joining. Like I said, the recording and the slides will be up in the archive section of our virtual chapter website. Thank you all.
Thanks, y'all. I enjoyed this. So thank you very much.